Hello, hello. All right, you guys are like one school day away from a 3-day weekend, which must be very nice. And I am, let's see, what is this, Thursday? So I would be 2 days away from returning from Florida. I'm probably getting very tired of my in-laws at this point and really enjoying the pool. Doesn't that sound nice? A pool, guys, and sunshine. Are you jealous? You should be jealous. Okay, so today we're talking about using p-values to complete a hypothesis test. We talked about rejection regions last time, and this is another way to do the exact same kind of test. But both ways, both methods are on the AP test, so it's important that we talk about both. You're going to find that a lot of this is very similar to last time, and we're going to do pretty much the exact same process as last time, as in we're writing directions and a remember sheet because we really like these. We're going to do example 3 together, and example 4 is going to be what you get to do alone. So we're going to start with the first direction, which is to verify that sigma is known and the sample is normal, or n is greater than or equal to 30, central limit theorem again. So it has to be normal, or n is greater than or equal to 30, but sigma has to be known. That's the big thing here. Sigma has to be known. This is in the problem. All right, flipping the page, jump into example 3. Step 1. In auto racing, a pit stop is where the racing vehicle stops for new tires, fuel, repairs, and other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of a race. A pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. A random sample of 32. Oh, 32. Okay, so we already know that n is greater than or equal to 30. Check. Doesn't even matter if it's normal now because we've already got that one. It looks like our x bar must be 12.9 seconds. Population standard deviation, that's the word I'm looking for. Population standard deviation is 0.19 seconds. I'm not sure I explained yesterday the difference between x bar and mu in a problem. Obviously, x bar means sample mean, mu means population mean, but in the examples of hypothesis testing, the mu is whatever your null and alternative number is. That's in your claim, which I'm guessing you guys figured out by just watching me do the problems, but I'm not sure I said it. Step 2 is to state the null and alternative hypothesis. And the claim. Either the null or the alternative can be the claim. Remember, pause anytime you need to. Step 2. All right, H sub O, H sub A. Let's see. It says here that they claim that their mean pit stop is less than 3 seconds. So their mean is less than 13 seconds. And that's their claim. I chose to put it on the alternative because it doesn't have an equals to. Opposite of that is greater than or equal to 13. Step 3 is to specify the level of significance and decide which type of test it is. This could be a left-tailed test, a right-tailed test, or a two-tailed test. Level of significance, remember, is alpha, and it also helps to draw a picture. All right. So if I draw a bell curve, let's see, this one is going to be less than. So less than is definitely a left-tailed test. H sub O is in the middle here. And alpha in the problem is 0.01. Now the big difference between a critical value, a rejection region type problem, and a p-value problem is that in a rejection region problem you're comparing z-scores, and in a p-level problem you're actually comparing areas. So we're not actually going to find out what the z-score is for this line. We're just going to compare the p-value, the probability, to this area. So you got to kind of imagine that this area adds up to 0.01, and we're going to compare the other area to that without finding any z-score to compare to at all. All right, step 4 is to find the standardized test statistic. Same formula as before, z equals x bar minus mu over sigma divided by the square root of n. This is your sample mean, that is your claim. This one's the population standard deviation and your sample size. Okay, so it looks like when they did a sample of 32 pit stop times, they ended up with 12.9 as their sample mean. Then I'm going to subtract what our mu was over here in our null alternative hypothesis, that's 13. Divide by 0.19 divided by the square root of 32. Remember to put parentheses on the top and the bottom. This is going to get you a z-score, but remember, we're not going to compare that z-score to anything. We're actually going to use that z-score to find an area. So I've got 12.9 minus 13 divided by 0.19 divided by the second square root of 32. I got a z-score of negative 2.98. Okay. So next you find the p-value. P-value is an area. By the way, I'm adding step 7 down here again. So if it is a left-tailed test, you just look it up on page A16, look up the number, the area to the left is already highlighted. If it's a right-tailed test, you're going to look the number up on A16 and then subtract it from 1. So it's going to be like 1 minus A16 is the final answer. A two-tailed test, you look up that value on A16 and then you multiply by 2. Maybe I'll get rid of this so it doesn't look confusing. Just make it A minus or 1 minus A16, whatever that turns out to be. And the reason for the two-tailed test is because when you look it up on A16, I'm talking about the z-score chart, by the way, if you're wondering what that is. If you look it up on the z-score chart, that only will tell you what the area in one tail is. So you need to multiply by 2 to find the area in both tails together. I will be doing one like that as well. That's example 4. So let's try this. For step 5.